Hello students, today we will start. The next topic is error detection and corrections. Any type of transmission is not 100% error free. The data link layer has to ensure that there are no errors in the transmission frame. Send and receive properly. Error detection is the process of detecting the errors during the transmission between sender and receiver. Here the error correction is the process of detecting errors in transmitted message and reconstructing the original error-free data. Error correction ensure that corrected and error-free messages are obtained at the receiver side. Data link layer has to take into accounts the transmission errors, and there are two ways to do this. First one is the error correcting codes. Include some redundant informations along with each block of data so that receiver can know that what the transmitted data must have been. And second method is error detecting codes. Here only enough redundant information is added with data so the receiver can know that the error has occurred but not with which errors and can request a retransmissions. Here the first method is or first way is error detection code, that means CRC. And error detecting codes are widely used on wireless link, and this technique is more efficient, so it is preferred. The correcting code requires a large number of extra bits to be transmitted. A parity bit can be used to detect an error. A single parity bit is added to a block which can detect a single bit error. But if two bits change, then an error will be not detected. The other technique is known as the polynomial code, is also known as the CRC, that means cyclic redundant check. It is used, and bit string are represented as the polynomial with the coefficients of 0 and 1. Here the CRC, that means the cyclic redundancy check, is a redundancy error technique used to determine the errors. In the CRC method, a certain number of check bits, often called as the checksum, are appended to the message being transmitted. The receiver can determine whether or not the check bit agree with the data. In the encoder, data words has k bit and code words has n bits. Size of 0 to be argumented is n minus k bit to right hand side of the data, and the generator use the divisor of n minus k plus 1 bits. Here the when the technique is used, sender and receiver must agree upon the generated polynomial, and here the checksum is calculated, and if there is a remainder and there is a transmission error. Here this is the rules. First one is the find the length of the divisor L, then second is append L minus 1 bit to the original message, then perform binary division operations by XOR and remainder of the division, that means CRC, and here the CRC must be L minus 1 bits. Here the operations, how to perform the operations in the CRC, these are by the XOR. Suppose this is the data 00 1 1 and B is a 0 1 0 0 0 1 0 1. Remember that when the data is 0 0, that then answer is 0, and when 1 1, then the answer is also 0. Just reminder, the data is 0 1 or 1 or 0, that means 1 and 1. Otherwise then the two similar elements, that means 0 0 and 1 1, their answer is 0. Here one of the examples for CRC. CRC is the different approach to detect if the receiver frame contains valid data. This technique involves binary division of the data bit being sent, and the sender performs a division operations on the bit being sent and calculates the remainder. Before sending the actual bit, the sender adds the remainder at the end of actual bits, that means actual bits plus remainder is the code word. Here this is the message 1001. Here this is 1001. This is the message. When when we solve these examples, this data is provided, that means 1001. This is the message provided you, and this is the divisor 1011. Here this is the divisor. You can this divisor is provided directly, or also this divisor is provided in the form of polynomial. For example, suppose x raised to 4 plus x plus 1. Then you have to calculate this divisor. How to calculate? This is the simple polynomial and generate into the binary form this message after the 4-bit append, and you have to convert this polynomial. Suppose here the x raised to 4, that means this is the number of 4 elements. First is 4, that means 1. Here the absent 3 2 is absent, that's why here the 3 0 2 is 0. Here the x raised to 1, that means x is here the x is present, and 1 is here. This is the x raised to 0, that means 1. Here the 1 is available. So that's why this is the divisor 10011. But here we have already provided the divisor 1011, and message is 1001. We have performed the divisor and questions and reminder. So how to calculate this CRC? Just divide the this is the divisor, and divide by 1 and 1011 first time. Then perform the operations by XOR, that means the when appears 1 1, that means 0, and 0 0 means 0. Two different elements appears, then answer is 1. Here first 1 1, first element ignore all the times, just last three digit operate. 0 0 means 0, then 1 1 means also 0, and 0 1 means 1. This is the first operation. Then remainder is here 0 1 0, then next bit is appear, that means 0. Then 0 1 0 0, this message is available. Then divide the message by 0, that means this 0, here the divide by 0, so 0 0. When first element leftmost bit is 0, then use the 0 divisor, so that's why here the 0 and here the 0, and this is the remainder 1 0 0 0. Then again divide by 1, that's why here the 1, and 1 0 1 1. Perform the operations 0 0 0. Then first remainder is remainder is not considered, and then second 0 0 means 0, then 1 0 means 1, and 1 0 1 means 1. Then appear the next element, that means 0. Here the new message is 0 1 1 0. Here also leftmost bit is 0, that's why we can divide by 0, so here the 0 and 0 0 0, and the remainder is here 0 0 means first bit is not considered, that's why here the 1 0 means 1, then 1 0 means 1, 0 0 means 0, and this is the final remainder 1 1 0. Here the code words means data words plus remainder. Here our original message is 1001, that's why this is the data words, and remainder is 110, that's why this is total code word. This is called as the CRC. Here this is remainder means CRC, here this is the CRC, and the code words means data word plus, here actual data plus remainder is called as the code word. The sender perform a division operation on the bits being sent and calculate the remainder. Being sending the actual bits, the sender add the remainder at the end of actual bits. Here the actual data bit plus the remainder is called as the code word, and the sender transmit the data bit is the code words, and other end the receiver perform division operation on code word using the same CRC divisor. If the remainder contains all 0, then the data bits are accepted, otherwise it is considered as there is the some data corruption occurred in the transmissions. Here this is the sender side and this is the receiver side. Here this data, this is data bits, or this is also called as the message is provided, and divisor is also provided you when you have to ask this example in your examinations. Then these two data is provided, divisor and message. Here first one is the message 11001 and divisor is 101. Then perform these operations by XOR operations. First divide by 1, so 1 1 0 1, and first digit neglect. Then here the 1 1 means 1 and 0 1 means 1. Then appear the next 0, here the next 0, so data becomes 1 1 0. Again divide by 1, that's why here is 1 and 1 0 1. One first bit is neglected and second is 0 1 1, and here the 1 0 means 1, and then appear the next bit, that means ones, and new data is 1 1 1. Again divides here the 1 0 1, then here the data becomes, first bit is neglected and second times this is the 1 1 0 means 1 and 1 1 means 0. This is the CRC from the sender side. But receiver sides, we have to add this CRC into the original message, and original message is 11001, and we have to add this CRC, and CRC means 1 and 0. This is the CRC. Remainder is called as the CRC at the receiver side. That's why at the receiver side this new data is generated adding the CRC at the last, that means this 10 is added at the last this original data. Then divisor is same at the sender and receiver side. Then divide the 101 first time 1, then here the 1, and this is the remainder, then 0 appear, then 1 appear, then 1 appear at the last. When we calculate these all operations, here the remainder becomes 0 0. That means if we have already know the rule is if the remainder contains all 0, the data bits are accepted, otherwise it is considered as the some data corruptions occurred in the transmissions. Here the remainder is 0 0, that's why here this is the error free, that means no error occur in the transmissions. This is called as the error detection code and the CRC methods. Then second is the data link layer protocols. These topics we will see in the next lecture.